Hello everyone, today I will talk about our paper on calibrating a global food trade model. Calibration means find a right experiment value so that the model can match real-world data. Our contribution is found a new way to make this process much more faster. First, the problems. Our model is a high-level, high-dimension global trade models with like all over the world countries set as agents and 97 food categories. To calibration it with a Bayesian method or like the GAs, we need thousands or maybe more than 10,000 of simulation runs, but usually tools you use the interface called net logo in every run is a slow process. We have been check if we want to run like the 100 runs, it maybe takes 13 hours. With thousands of runs need, becomes almost impossible. Here is our key idea. So we call that the pre-computed result maps. Instead of call the models during the statistic interface, we separate the work into two stages. Stage 1, we run all the simulation we need for one generation as a big batch of the independent task on the HPC cluster. Then the results are saved in the lookup table. So the stage 2, we use the ABC-SMC algorithm run like a local computer. We just simply read the table. It never touched the net logo. So we repeat this for each generation until the result converge. This removes the interface bottleneck. Does it work? Yes. Compared with the standard GUI models, our HPC setup is 42 times faster. The chart shows that times run 100 simulations over 30 hours on GUI models, several hours with PyNet logo or RNet logo with the no GUI models, but only 90 millions with our approach. The speed makes full Bayesian calibration of a high dimension models, particular for the first time. So our second result is about the quality, not just the speed. Unlike the normal optimization, which gives the one best numbers, the ABC-SMC gives over 4 Poisson distribution with 95 credible intervals. So we know how certainly we are about each parameter. We also cross-check with the genetic algorithm is the best answer, fairly inside our intervals. So instantly, the two calibration target behavior very differently. For in our models, the match trade partners need small weights, where the match trade volumes need a very large weight on the history trade. Clear evidence to show the pace dependence. And the sensitive analytics shows the GDP is the most influenced parameters. So finally, our pre-computing result mapping strategy separate simulation from the interface, and it works for every simulation that supports batch runs, not just net logo. Second, we got 42 times speed up without losing statistic rhythm. Third, the results give us a new insight with the trade partner choice, and the trade volume seems to be driven by different mechanisms. The code is open on GitHub. Thank you so much. I'm happy to take a question.